according to the theory of evolution, the origin and development of the universe and all its systems can be explained solely on the basis of time, chance, and continuing processes. All living things have arisen from a single-celled organism. A second and opposing worldview is the concept of creation. According to the theory of creation, everything in the universe has come into being through the design, purpose, and deliberate acts of a supernatural creator. That means this creator created the universe, the earth, and all life on earth, including all types of plants and animals, as well as humans. On today's edition of Origins, find out how fearfully and wonderfully made you are.
Hello, my friends, and welcome to Origins. It's a joy to have you with us today. Origins is a forum where we take the evidence of science and use it to validate the truth of creation. We have a great guest with us today, one of my very favorite guests. His name is Dr. David Menton, and he was a professor for 34 years at the School of Medicine at Washington University in St. Louis, Missouri. And he's here today to talk to us about the whole birth process of a human child. And one of the phrases that comes to mind, we're going to read it from Scripture here in a few minutes, is fearfully and wonderfully made. That's how the psalmist describes our creation. Dr. Menton, what a joy to have you with us.
My pleasure, Doc.
Now, today we're going to talk about babies. Everybody likes babies.
Yes, isn't that a cute baby we have?
I'm telling you, that is a great
today
baby.
There's
a little that goes into the process before they get there, isn't it?
Okay.
I guess we were talking just before we went on the air, and I was going to ask you, when does life begin? But you said that's not the right question. What's the right question?
No, I think if we were asked the wrong question, we're probably never going to get the right answer. And the reason when does life begin is the wrong question is that everything is alive. All life comes from previously existing life, so there is no beginning ever since creation. Even the uterus is alive. The egg cells are alive, the sperm cells are alive. Hey, our big toe is alive.
Yeah, I hope so.
So I think a better question is, when does a person begin in the womb? And I don't think that's a kind of question that science has an answer for. I think the only place we can go to get an answer to that question is to Scripture. And
so that's where you would like to start, with some Scripture, is that right?
I think that's where we need to begin to address that interesting question. And we'll begin with that famous Psalm 139. For you, that is God, created my inmost being. You knit me together in my mother's womb. We see that word knit so much in the Bible, that we were woven and knit, and I see that certainly when I look through the microscope at the human body. We are indeed knit and woven. It goes on to say, I praise you because I'm fearfully and wonderfully made. Your works are wonderful, and I know that full well. In other words, it's pretty obvious that we are fearfully and wonderfully made. The psalm goes on to say, and this is a beautiful verse that I think has a lot to speak to us today. It says, my frame, my body, my bones, if you will, my frame was not hidden from you when I was made in the secret place. It's sort of a euphemism for the womb. When I was woven together, there it is again, in the depths of the earth, another euphemism for the womb. Your eyes saw my unformed body. All the days ordained for me were written in your book before one of them came to be. I think the key here is that it says that God's eyes saw our unformed body. That means that as the body was forming in the womb, God was looking on.
Yes.
And, it's a kind of a terrible thought, but when a baby's aborted, I can just imagine somebody going in and just tearing that forming body out away from the very vision of God, right before his eyes. And that's why I think this is such an important issue.
When it says that God saw the unformed body, he's not just a passive observer, is he?
No, that he certainly is not.
He's active.
He's active. He's forming. He hasn't just wound up a clock and let it run. When an egg is fertilized and that egg implants in the womb, that whole step from fertilization on, if we do not interfere, a baby will shortly ensue.
Yes. Well, how does this begin?
Well, let's just go up and look at some of the events that happened as we develop from the very beginning. Okay, this is the uterus. It sets down low in the pelvis, and on either side of the uterus we have two structures, one over here, one over here. These are the ovaries, and it's in these ovaries that the eggs are produced. And you know, Don, when a baby girl is born, as soon as she comes out of the womb, she has all of the eggs in that ovary she's ever going to have in her whole life.
Well, you said the eggs are produced there. When are they produced?
Well, they're produced during the development of the baby in the womb, so that by the time the baby girl is born, they're all ready to go.
Wow.
And then when the girl reaches sexual maturity and begins to ovulate every 28 days, these ovaries are courteous. 1 month, this one ovulates, the next month this one, and they take turns back and forth. And you know, if one of them becomes defective or removed, the remaining one has the great good sense to ovulate every month.
Wow.
Notice next to the ovary is the oviduct. It's a tube on each side of the uterus. It runs up here, ends right here, and it has a kind of a funnel. Notice the funnel shape. And when the egg is ovulated, it's the job of that funnel to catch the egg like a catcher's mitt. If it were to miss, the egg would be out here in the peritoneum, and it could, in fact, if it were fertilized, implant there, and that would represent a medical emergency. Let's just follow the development of the egg in the ovary. As I mentioned, there's about 400,000 in here, and once the female reaches sexual maturity, each 28 days, about 40 or 50 of these eggs being stored, ready to go, will sort of begin to develop, will become larger. Cells will develop around the egg, and you get what we call a follicle. This is a follicle right here. It's kind of a big hollow ball, and the egg is right inside here. And the idea is the egg is going to be ovulated, that is, it'll be ejected right out through the wall of the follicle to be caught by that oviduct, the catcher's mitt, if you will. Now, as soon as that egg is ovulated, the remaining cells of the follicle that are left behind go on to form an endocrine organ that makes special hormones that will be necessary for the development of the baby. But if a signal is returned that says basically fertilization did not occur this time, then this endocrine organ that is built up from the remaining cells of the follicle will break down. And when it breaks down, it forms a large scar in the ovary about this big. So big that you can see it in an ovary without benefit of a microscope, just with the unaided eye. And each month another scar is formed, and within 4 or 5 months, the whole ovary would be nothing but scar tissue, and that would be the end of life right there. All ovaries, a solid mass of scar tissue. And you know, the medical profession has never found a way to dissolve scars. Most of us have scars in our body that have been there for our life and will continue to be there. But you know, the Lord has a miracle here. The one place in the body where a scar is completely dissolved. Boy, would plastic surgeons like to do that.
Yeah.
And here it is in the ovary. And if it were not so, this would be the end of the lecture right here, Don. We wouldn't go any further because the egg would never be getting out of the
I've got a feeling
ovary.
you and I wouldn't be here to talk about it.
That's right.
Yeah.
So let's move on. We've got a cutaway here of the ovary.
Amazing.
And the oviduct. The egg will go right in there, and the idea is it will be fertilized someplace right about here, in the oviduct, and then it will continue to move down the oviduct into the uterus and will implant like a seed in the wall of the uterus. Now, to get that egg to move requires something just spectacular. We're going to look at that area enclosed by the box. These are the lining cells of the oviduct. They have little hairs on the surface. Of course, they're really not hairs, they're cilia. You can see them right here. I'll just sort of draw lines for them. They're all along here. And these cilia beat. Now, if they just beat like this, the egg couldn't move down the oviduct. If they beat like window wipers, like this, the egg would go back and forth. It wouldn't work. That'd be the end of life right there, Don. I mean, we couldn't go on with the lecture. But we know that the cilia beat in a way that is really extraordinary. It's called a metachronal rhythm. Let me show you what that rhythm looks like. This rhythm, and only this rhythm, it's the same thing you see when you see wind blow across a wheat field, or if you've seen them do the wave in the ball stadiums.
Yes.
This is it. Millions and trillions of these cilia down the oviduct must all beat in concert in a metachronal rhythm, or the egg doesn't go down the oviduct. If it would be fertilized but not go down the oviduct, you'd get a tubal pregnancy. That'd be the end of life right there. We wouldn't have to worry about anything beyond this. It would be over. But
so it's not just a miracle that God's put these cilia in there to move the egg, but the pattern with which they move is in and of itself miraculous.
It must be perfect.
Yes.
It must be integrated. Each cell would have hundreds, perhaps thousands of these cilia, and then millions and millions of cells, and all of the cilia working in concert along the entire oviduct to move the egg, without which, no life.
You know, I think of, you ever seen the pictures at the rock concerts where they pick someone up and they pass them down through the crowd? That's sort of what the cilia are doing with the egg. That's right.
And the egg is being passed down through the oviduct. Let's look at the timeline, Don. The egg is ovulated here at step 1. Fertilization typically occurs 12 to 24 hours. That's the window of opportunity for fertilization. It occurs right at the beginning of the oviduct. If fertilization occurs, then the egg moves down the duct, being moved by the cilia. At 30 hours here, 30 hours, we have the first division of that egg. It's really not an egg anymore. We call it a conceptus. And when that divides, we get a zygote, which is a little ball of cells. You can see it down here at 3 days. It's a little ball of cells that have divided. And at about 4 to 5 days, this ball of cells enters the uterus. This is after ovulation, and it's at this time that the ball of cells becomes hollow, we call it a blastocyst, and implants into the wall of the uterus like planting a seed in the soil, and the soil of the uterus is prepared just optimally to accept this at this time. Let's look at an egg actually moving down the oviduct. This is not fertilized yet. It's inside the oviduct, in this case a mouse. And around the egg, here's the egg here, is a large group of cells. These cells are called the cumulus cells. They accumulate around the egg. Were it not for these cells, it would be the end of life, Doug. The reason is the cilia cannot move the egg unless they contact these sticky cells here. If you strip the egg away from these cells, put it in the oviduct, it just sits here and spins.
Okay.
So we need to have the sticky cumulus cells. Here they are at a higher power, and inside the egg, this is the egg here, we see the chromosomes themselves, this little dot here, and those are the chromosomes that will be met by the chromosomes of the male sperm. If the two get together, from that moment on, the baby will develop. And here we get to a step that we will cover in the next part of our presentation.
That's right. Well, we've got to take a break, so just tell that egg to stay there for a minute, and don't you go anywhere either, and we'll be back right after this break.
Creation versus evolution, you weigh the evidence. The human brain, a marvel of engineering. The brain has over 10 billion nerve cells. It also sends out electrical impulses at almost 300 miles per hour and receives 2,000 responses per second. The brain constantly receives signals from 137,000 light receptors in the eyes, 100,000 hearing receptors from the ears, 3,000 taste buds, 30,000 heat sensors on the skin, 250,000 cold sensors, and 500,000 touch sensors. How can anybody believe this magnificent structure was not designed? Today's guest on Origins, anatomist Dr. David Menton, is a speaker for Answers in Genesis. Audiences enjoy his well-illustrated presentations on a variety of fascinating topics. Many of these lectures are available on DVD. If you're interested in the subject of creation, you'll definitely want these for your own. Orders are being taken at 800-778-3390. You can also write to Answers in Genesis, P.O. Box 510, Hebron, Kentucky, 41048, or visit the website at www.answersingenesis.org.
We're back with Dr. David Menton, and we're talking about how we are fearfully and wonderfully made, and the process of birth. And Dr. Menton, I've noticed, I think I've counted 3 times already that you've talked about it being miraculous, what's happening inside the uterus, as that if it didn't happen just this way, life would be over. But God has made it so it works.
Let's look at that process.
Great.
You're going to see several more miracles in my view. Yes, we have some scientific explanations, but you can only go just so far with these explanations. First of all, in the vicinity of the egg, and we see the egg here, and we notice the egg is surrounded by this kind of a red shell here. And yes, the human egg does have what we might call a shell. It's not a hard shell like in a chicken. It's like the scum of Jell-O. It's a kind of a rubbery gel. We call it the zona pellucida, which just means the clear layer. And it goes all the way around the egg. And then, as you know, around that would be this accumulation of cells that make a sticky substance that the cilia use to move the egg. Okay. There would be probably, if fertilization is going to occur, several sperm in the area, probably a few hundred. Only one must be allowed to fertilize the egg. So one of the first challenges we have is, how do you keep every sperm cell except one from fertilizing? This is a fabulous story right here. Wait till you see it. Here's a sperm that we'll say has gone its way in. The first barrier that it comes up to is the sticky material of that cumulus. There's no way it can get through that cumulus, except a special enzyme is secreted by the head of the sperm that digests a channel through the cumulus.
It literally eats its way through. In
Absolutely.
A sense. Yes.
It takes a specific enzyme to do that. Oh. You are now at the zona pellucida, and there isn't any way you're getting through the zona pellucida, except there is a second special enzyme.
2 different enzymes.
2 completely different ones located in different positions in the sperm head that specifically digest its way through the zona pellucida. It's not over yet. You've just reached, actually we should come in over here because there's a gap there. You've reached the cell membrane.
Okay.
And there's no way that that cell membrane is going to allow this foreign sperm cell, which is from a whole different person, different genetics, different membrane. How do the 2 ever get together and the egg allow the sperm in? We really don't know the answer to that, except we know that as soon as the sperm head touches that egg membrane, there's some kind of a chemical recognition that goes on that identifies that, yes, this is a sperm. It's of the same species. And if it is, that sperm's membrane fuses with the egg membrane, and the sperm enters the interior of the egg. Now, what about all the other sperm in the vicinity? They might have gone through the cumulus and through the zona pellucida to different degrees. But the first sperm head to touch the membrane of the egg initiates an incredible response from the egg called the cortical reaction, in which little granules break and secrete an enzyme called ovoperoxidase that goes out here to the zona pellucida all the way around the egg and instantly hardens the zona pellucida, stopping all the other sperm cells in their tracks.
So it kind of counteracts the enzyme that would break it down. It makes it so it doesn't break
That's
down.
right. It hardens the whole zona pellucida. And what this means is that polyspermy, that is more than one sperm fertilizing,
Right.
is very rare.
Yeah.
When polyspermy occurs, the whole system spontaneously breaks down. In other words, you cannot go on with polyspermy. It's the end of that particular event. So even that's terribly important. Now, there's a series of, 3 or 4 miracles right there just to get the egg fertilized.
Amazing.
But you haven't seen anything yet. We now have, and don't ask me which is which here, Don, I really don't know. This is inside of a human egg, and one of these 2 groups of chromosomes is from the male, and one is from the female that's been in the egg all along. We still don't have fertilization yet. The sperm's in here, but it isn't fertilized. But when these 2 groups of chromosomes fuse together, combining the DNA of a mother and a father, that's the beginning of a new human being. Well, here's the first cell division. At about 30 hours after the ovulation, that fertilized cell will divide to make the first 2 cells of the baby's body. Notice we still have the zona pellucida running out here. Do you see it around the edge? Sometimes the zona pellucida is defective or breaks down. And if it does, these 2 cells, number 1 and number 2 of the first 2 cells, can break apart, separate. Oh, this is a heady thought now, Don. I don't want you to think about this too long. But if they separate, you get 2 babies. And if they stay together, you get 1 baby.
I got it. Twins.
Well, a special kind of twin. You see, most twins are 2 different eggs fertilized by 2 different sperm. It was a multiple ovulation.
Right.
But these would be identical twins. They're virtually a clone. But they're God's clone, and only God's clones really work properly. The clones that we make, like Dolly the sheep, are very short-lived. So it's a heady thought to think that each of us could have been 2 people.
Wow.
But because those cells didn't separate, we're
Stay
one.
together, yeah.
And I just leave that up to God, because I can't figure that one out. I just say, Lord, you know, I don't know. From 2 cells, it divides, we get 4. They divide, we get 8. And this little ball of cells, called a zygote, will finally enter the uterus. When it enters the uterus, a hollow chamber will develop inside. We call this a blastocyst. The amazing thing is, do you see the cells in blue here?
I do.
They are the baby. It's the only part of this group of cells that is the baby proper. You might wonder, what are all these red cells going around out here? That's really a fascinating story. Those cells will make the placenta.
Yeah.
Because you see, this baby is going to wait while the placenta develops. And these cells that make the placenta actually burrow through the wall of the uterus, something that really should never happen. But it does. Burrow through the wall of the uterus, penetrate inside, and only when the placenta develops to a certain point to support the developing baby will these cells that actually make the baby continue on to develop and
So the progress of the baby itself actually stops until the placenta has both rooted in the wall and has developed sufficiently to support it.
That's right.
Yeah.
It has to begin to develop. And these cells, as they penetrate, actually fuse together, forming a huge cell. We call it a syncytial cell. And this will penetrate. This is the way that actually looks in the flesh. This is the inner cell mass right here. That is the baby in a human. And these cells out here are called the cytotrophoblast. And they will make that most wonderful of all organs in the body, the placenta.
Wow. Well, this is part 1 of a 2-part show. Come down here and join me as we get ready to wrap this up. But My friend, it's been a joy, and we're going to do a second part of this show, and I want to say to you that you'll want to be assured to be a part of that show, because we've got, as they say, more of this story to tell, and it's just as miraculous from here on as it was up until this point. How marvelously God has made us. We'd love to hear from you. Write to me at Origins, Cornerstone Television, Wall, PA 15148, or get in touch with us through the internet at originstv.org. Let us know what you think, and let us know if we're speaking to the needs in your life as we talk about the awesomeness of the way God has made us. You know, it's God's view that He made you. And don't forget, that should be your worldview too. God bless you until we see you next time.
Thank you for watching this edition of Origins. If you'd like a copy of the PowerPoint information presented today, you can download a PDF file of program number 511 from our website at www.originstv.org. Or for a DVD of this series, send a $12 donation to cover shipping and handling, and write to Origins program number 511, Cornerstone Television, Wall, Pennsylvania 15148.
Origins is made possible by the faithful prayers and the financial support of you, our Cornerstone Television family.